Hello all, welcome back. So in this today's session, we'll try to understand. So the first agenda or objective is of today's class is that first we are going to see that what is clock signal and how clock signal will be useful for digital circuits. Once it is completed, we'll see what is the meaning of the counter and what are the different types of the counters, right? So based on how we are applying the clock signal, we have some classification. So that is the thing we are going to discuss in the today's session, right? So first we'll see right, what is the use of the clock signal or clock pulse. So if you read this one, digital circuits, any kind of digital circuits that relay or depends on the clock signal to know when and how to execute the function that are programmed. So what do you mean by this one is, as in the previous classes we have explained flip-flop, right? Suppose for example, if you say I'm going to consider some s value something like this, some r value I'm going to consider something like this, right? Now if you see here, if I'm going to take this particular point of the interval something like this, right? So this is my interval, right? Some certain time duration, let it be t1 or something. So this is s value, this is r value. I need to find out the output, nothing but the qn value, right? In which duration we need to find out? In this duration we need to find out what is the output value, right? So remember that the moment if you are giving s equal to 1, r equal to 1 or something, if you are giving some other value also, you cannot able to get the output value. The reason is that how all these digital circuit will be depends on relay on the something called as the clock signal or clock pulse, right? So to know when and how to execute the functions, nothing but if you want to execute this function, it is completely depends upon the clock signal value. It means that what is the meaning of clock signal? So it may be either from continuously 0 to 1 or 1 to 0, 1 to 0, something like this. So this is what we called as the clock signal. It means that initial value is 0, this high value we called as the 1, next value 0, 1, 0, 1, 0, 1. So look like we will be having the clock signal something like this. Now if you want to get any operation, first we need to apply something called as the clock signal value. It means that, right, we have the two options, when clock equal to 0, when clock equal to 1, right? If clock equal to 0, it will not perform any operation. It means it will perform the, it will copy the previous output of the previous state. When clock equal to 1, then only according to your input value, something you are giving s equal to 1, r equal to 1, right? So then only you will be getting some output value. It may be invalid or no change, it may be 0 or 1. So based on the clock pulse only, after giving the input, you will be getting the output, right? Now if you read this statement again, digital circuit relies on what? Clock signal to know when and how to execute the function that are programmed. If it is 1, then only according to your input you will be getting the output. If it is 0, you will be not getting the output, you will be getting the no change operation or memory operation, right? So so you see, a signal is used to synchronize the operation on the electronic system. Clock pulses are continuously preciously spaced change in the voltage, like 0 to 1, 0 to 1. 1 means something we are applying 3.3 voltage, 5 volt, whatever it may be. 0 means we are applying the no voltage, nothing but the 0 voltage, right? So spaced changes in the voltage, right? So from this point of thing, you need to understand one thing. So every operation will be performed based on the clock signal operation only, right? Now as we discussed in the previous classes, flip-flops are example for what? Flip-flops are works based on which mechanism? So it will work based on the edge triggering mechanism, right? So again, edge triggering mechanism we have two types. One is called as the positive edge triggering, or we can call it as the rising edge, and second one we called as the negative edge triggering or falling edge triggering, right? So what do you mean by rising edge triggering? Means suppose for example here we have the clock pulse something, right? As we said that what is the meaning of clock signal, right? So the operation clock pulses are the continuous, right? Something like 0 1 0 1, something like this. Now see that what is the meaning of the rising edge. If value changes from 0 to 1, then it is called as the rising edge. See, if the value is changing from 0 to 1, something if you observe here what is value? It is changing from 0 to 1, right? So this is we call rising or falling. So if it is changes from 0 to 1, it means this is the rising edge, or we can call it as the positive edge triggering. Now where here if you consider the clock pulse, right? So something I am considering the clock pulse. If you want to find the output based on the edge triggering mechanism, so here only it is changing 0 to 1, right? So this edge we called as the positive edge. For next one, this is the value, right? Changing the 0 to 1, right? This is the positive edge. For the next clock pulse, this is the positive edge. It means that this is the starting duration time period, this is the ending duration time period. So based on these sets we are going to find the output, right? Then it is called as the flip-flop is works based on the clock signal. What type of clock signal it is? Positive edge or rising edge clock pulse. Now what do you mean by negative edge or falling edge, right? Suppose if I take the same clock pulse value, I need to find out if I am using the negative edge clock pulse value. So negative edge clock pulse means if the value is changing from 1 to 0, right? See that if it is something changing from 1 to 0, it is called as the falling, right? So that is another name for the falling edge is the negative edge, right? So see that this is called as the negative edge means down arrow mark, positive edge or rising edge means up arrow mark. Now this is the positive edge, right? But what we are trying to locate negative edge, right? So this is changing 1 to 0 is the negative edge, negative edge, negative edge. So based on the starting clock pulse, ending clock pulse or edges, we are going to find the output value. So all flip-flop work based on what mechanism? Edge triggering mechanism. So one is positive edge triggering, another one is the negative edge triggering. If you see that this is the clock pulse value, right? This means 0, 0, 1, something like this. So this red color indicating the changes the value from 0 to 1. Changes the value from 0 to 1. All 0 to 1 are called as the rising edge or falling edge. So what is this blue color indicates? These are the changing the value from 1 to 0, right? Falling edge, falling edge, falling edge. Right? So we are going to design the counters by using either falling edge or we are going to use the either rising edge mechanism. Right, now we'll see that how to find out or how to represent the positive edge or negative edge mechanism. Suppose if I say any flip-flop, suppose for example if you take SR flip-flop, right? So here we have the one more is clock pulse, right? So if something is like this is a normal value or enable line. So if you make something edge is like this is called as the positive edge. But if you make bubble along with the edge, it is called as the negative edge or falling edge. If something is look like your clock pulse, then it is called as the positive edge. If something look like with the NOT gate or bubble operation, it is called as the negative edge. Now what is the type of clock pulse? It is normal enable line. If I take this one, the meaning is that it is a positive edge. If I keep bubble inside of this one, it is called as the negative edge representation. So from here, what is the point you have to understand is, right? So digital circuits that is completely rely on the clock signal to know when and how to execute the functions, right? It means that the moment you are giving the input, you will be not getting the output unless otherwise there is a activation of the clock signal, right? So this is the one point you have to remember. So edge triggering means we have the positive edge, negative edge. This is how we can represent. Now we'll see what is the meaning of counter, right? So counter is a sequential logic circuit, right? So a digital circuit which is used for counting the number of clock pulse is known as a counter. Simple thing is a digital circuit, right? So which is used for counting the number of clock pulse. Suppose for example, see you are giving some value, right? So some value, some S value you are giving, some R value you are giving, something you are giving. So here also we are giving clock pulse, right? Just it will count the how many clock pulse. This is the first clock pulse, right? Second clock pulse, right? Something, right? So a digital circuit which is used for counting the number of clock pulses is known as the counter, right? So what is the widest application of the counter is using in the flip-flop, where group of flip-flops with the clock signal is applied. Then based on the how we are applying this clock signal, this is important, right? So how we are connecting the clock signal to the flip-flops, we have the classifications, two main classifications we have. We will see what are they, right? So first one we called as the asynchronous counter or non-synchronous counter or ripple counter, and second one we called as the synchronous counter or parallel counter. Suppose for example if I take two flip-flop, right? Suppose I am taking the flip-flop 1, right? Let it be some flip-flop 1, let it be flip-flop 2, right? So let it be, you can consider any input whatever it may be. So just I am going to consider here edge triggering means either you can consider the positive edge or negative edge, right? So now question is that, so based on how we are applying this first flip-flop, second flip-flop clock pulse, we have the two classification. So one is called as the asynchronous counting operation, non-synchronous counting operation, as well as the ripple counting operation. So another one is called as the synchronous counter or parallel count. So first we will see the definition for the asynchronous counter, right? So what do you mean by asynchronous counter means? For example, here I have the two flip-flop, right? So what is the use of two flip-flop? As we said in previously, one flip-flop can be used to store the 1-bit information. If you want to store the 2-bit information, we require two flip-flop. If you want to store the 3-bit information means we require the 3 flip-flop, right? So suppose for example you can take any flip-flop. Just for example, I'm taking this is the first flip-flop, naming as the A. So input will be TA, output will be something like QA. Here we can take the QA bar. So one more input is the TB, right? Then outputs are the QB bar, right? So let it be just for understanding purpose. I'm taking this as A flip-flop, this is the B flip-flop. Now how we are applying the clock pulse? Based on we have the two types, right? So what do you mean by asynchronous counter means, right? So here we have the first flip-flop clock pulse, right? So if the first flip-flop clock pulse is triggered by external clock pulse. So what do you mean by external clock pulse means? Every time we need to provide this value, either 1 or 0, that we need to provide here. And the remaining all flip-flop, if you see there's a second flip-flop also we have the clock pulse, right? For the second flip-flop, right, what is the clock pulse means? The output of the previous flip-flops. Either we can connect QA or QA bar. If you connect QA, then you will be getting, for negative edge, you will be getting the up counting operation. If you are connecting the QA bar, you will be getting the down count operation, right? So later on we will see how we will be getting the up counting as well as the down counting, right? First flip-flop will be triggered by what? External clock pulse, and the second flip-flop clock pulse is nothing but output of the first flip-flop. Suppose if you have the third flip-flop also, let it be something TC, then output is QC bar, then one more is the clock pulse value. Now how to connect this clock pulse value, right? Output of the previous flip-flop, right? So what is the definition is, the only first flip-flop is driven or triggered by the external clock pulse or main clock pulse, and the clock input of the rest of the following flip-flop is nothing but this one is driven by the output of the previous flip-flop, nothing but output of this flip-flop is called as the asynchronous counter or non-synchronous counter. Now if you see that what is the meaning ripple counter, why they have given this name as the ripple counter means, now if you observe here one important point, see if you want to get the first flip-flop output is what? QA, right? If you want to get the first flip-flop output, we need to give the external clock pulse, right? Then only you will be getting the output for the first flip-flop. Now if you want to get the second flip-flop output is nothing but QB means, it is completely depends upon the output of the previous flip-flop, right? Because if the clock pulse want to be activated for the second flip-flop, it is connected to the first flip-flop output, right? It means that it should be generated the first flip-flop output, then only it will be given to the clock pulse or the second flip-flop, so that it will produce the output value, right? So what do you mean by this? Why we called as a ripple means, suppose if you throw some stone inside of water, what will be happen? First we will be getting some output value. Due to this wave, you will be getting the one more wave, then one more, right? Due to this one will be generated. Due to this one, this will be generated. Due to this one be generated. It means that after generating the first output, we will be getting the second, then after second you will be getting the third, because one after another. Due to previous one, we will be getting the next level. That is why it is called as the ripple counter, right? It means that at a time it won't produce the outputs one after another, right? So if the first flip-flop is triggered by the external clock pulse and remaining flip-flop clock pulse are nothing but the output of the previous flip-flop, then it is called as the asynchronous counter. Simple definition, right? Now we will see what is the definition for the synchronous counter. So same I am going to consider some 2 flip-flop or 3 flip-flop, whatever it may be, some flip-flop. I am going to give some ABC name. So this is TA, QA, TB, QB, right? Now see that we have here also we have the clock pulse, right? Now what is the meaning of synchronous counter means, if the common clock pulse is applied to the all flip-flop, then it is called as the synchronous counter. It means that we have only one clock pulse, that is the global clock pulse, that will be applied to the all flip-flop common. Now what is the meaning of this one? We have this clock pulse, right? This clock pulse is right. Now it means that if all the clock pulse will be commonly connected together, then it is called as the synchronous counter. That's it. Now synchronous counters are much faster than the asynchronous counter, right? So much faster than the asynchronous counter. How synchronous counters are much faster than the asynchronous counter means, now if you see that the moment you are giving clock pulse value equal to 1, this flip-flop will produce the output, the same time this flip-flop will be producing the output. In previous case, what is happening? It should first generate the output will be given to the clock pulse or the second one, so that it will be generated, After generating the second flip-flop output, it is giving the clock pulse for the third one. So it is generating the output, right? So it means that it is a slower, it is the faster operation. Why it is the faster operation? Because the moment you are applying the clock pulse, flip-flop 1, flip-flop 2, everything will work start together, so that you will be getting the output at a time. Simple definition. So asynchronous means first flip-flop will be triggered by the external clock pulse. External clock pulse means we are giving some external input data. All remaining flip-flops will be triggered by what? Output of the previous flip-flops. This is called as the asynchronous counter. Now what do you mean by synchronous counter? If the common clock pulse is applied to the all flip-flop, if 3 flip-flop, 5 flip-flop, whatever it may be, if the common clock pulse is applied to the all flip-flop, then it is called as the synchronous counter. Synchronous counters are much faster than the asynchronous counter. Why? Because it is works based on the common clock pulse. It is work based on the individual clock pulses, right? So then we have the some more counters, other type of the counters also. One is called as the up counter, another one is called as the down counter, another one called as the up down counter. If you see this example, what do you mean by up counter is, suppose if number is something 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If 10 count you are designing something, so this is how you will be getting the up value, from lower value to the higher value. So what do you mean by down counter? So it will from the higher value to the lower value, something 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. What do you mean by up down counter? First it will perform the up or down operation, again it will perform something called as the down operation. Right? Then one more point to remember is, something if count is 0, 0, 0, 1, 1, 0, 1, 1. It means that after applying, what is the definition I have given for counter? It will count the, right? So what is the definition I have given initially? It will count the number of clock pulses, right? So number of clock pulses that we applied. That is the definition for the counter. It means that what is the initial count value? Something 0, 1, 2, 3, something, right? If you want to change the count from 0 to 1, then 1 to 2, then 2 to 3, right? Now what will be happen? If count want to change from 0 to 1, we need to apply what? Clock pulse. Now how many clock pulse we are counting? 1. That is the meaning. After applying the one more clock pulse, count will change from 1 to 2. So how many clock pulse? Second clock pulse we apply. After changing the value, after applying the clock pulse, count will be changed from what? 2 to 3. One more clock pulse we are applying. Now what is the definition of counter is, once count is completed, it means that once it reaches to the, right, so maximum value, again it should return back to the what? Again it should return back to the initial count. It means that what is the maximum count here? 3. Once count is completed, again it should return back to the initial position. What is the initial position? 0, right? So how many clock pulse we required? For 4 counts means we required 4 clock pulse. This point you have to remember, right? So first applying, it will change from 0 to 1, then 1 to 2, 2 to 3. Once count is completed, it will return back to the initial position, right? So here we have the example, you can see. Now see that count is changing from 5, 6, 7, 8, 9. Again it is coming from 7, 6, 5, 4, 3, 2, 1, something, right? It means that it is the up counting as well as the down counting operation it is performing, right? Now see that. So what do you mean by this? You try to identify up counter or down count. So largest value to smaller value means this is the down counting operation, right? So in the next classes we will see how to design our up counting value as well as the down counting operations, right? Thank you.